So our second skill master for the day is Marian de Chavez. Marian finished her senior high school with a patent and copyright to her application research for the hearing impaired. She has seen the great benefits of doing research and she pursued STEM. She's currently in university doing projects on applied linguistics and computer engineering while on a hiatus in her technopreneurship startup. It's also her second term as a mentor with SIDHI, and she is always excited and ready to guide high school students in doing the research projects and keeping them on track. On the side, Marian loves visiting local skating communities in the Philippines to help them cultivate a healthy social life and advocate for the benefits and physical well-being of her fellow Filipinos.
First of all, thanks for having me here. I'm Marian Elaine de Chavez, BS Computer Engineering undergrad and Data Science scholar at Sparta. So I took this opportunity to share with you some information and some very useful information in data analytics, such as data analytics skills and computational linguistics for artificial intelligence. And I hope that you will learn a lot from this presentation. Overview, these are the stuff that we're going to discuss today. Design thinking for analytics, statistical tests for your research projects, computational linguistics, corporate analysis, and tools. Many of these are introductory, designed for high school students. So part 1, design thinking for analytics. Design thinking is the mindset for effective problem solving. It's a must for 21st century skills, since we are living in a very high-tech world. All right, the modes of thinking or design thinking are empathize, define, ideate, prototype, and test, some of which I think many of you are already familiar with, but we'll still run through them. So what is design thinking? As mentioned, it's a mindset, but it's not just a mindset that anyone can easily grasp, because design thinking is actually something that you cannot read from a script. It's something that we develop through practice. It's just like learning how to walk, to do maths and languages, something like that. So it's a skill that no one can take away from you. First is empathize. It's one of the most important. Empathizing is putting yourself in someone else's shoes. So as researchers, we cannot make assumptions on what the participants or the people we want to solve the problems with are going to need some things that did not come from them. Instead of assuming what they need, we have to actually immerse ourselves into their own environment and try to understand what really are the problems that they're experiencing and being objective with it. So in order to empathize, we must observe, we must engage, watch, and listen. Next is define. What is define? It's a mode of design thinking skills that where we try to funnel the problems or the information that we gathered from empathizing and try to make sense of it and be selective in addressing the needs of those persons. So define, we make sense of the information that we gather, or at least we try to make sense of them. Next is ideate. Ideate is a mode of design thinking where we try to brainstorm ideas and solutions, possible solutions that can possibly address the problems that we have defined through empathizing. Next is prototype. Prototyping is something we always hear. So it's a considered selection that through brainstorming are put into action, because when we prototype, we test, right? So it's not the ordinary kind of test, because sometimes as researchers or scientists, when we test something, we realize many things that, and also some things could go wrong. Some stuff might be missing, and we realize that we can improve upon it, and we go back to prototyping, or probably ideation again, or probably redefine the things that we have formulated. So it's not a linear process. It's actually much more flexible than that. It's really important in data analytics. Part 2, statistical tests for data analytics for your research projects. So when I was in high school and we're trying to formulate or design some solutions for certain problems, we're often confused of what statistical test would fit best in our research projects. So I'm here to give you an overview of the possible tests and where you can use them depending on your research project. Let's familiarize ourselves first and recall these terms. I know you're familiar with this. And mode, the frequent recurring value in the distribution. Median, middlemost number in the distribution. The mean is the sum of scores divided by the total number of scores, which we often use in our research projects. So that's a measure of central tendency. And some of the things here are not mentioned because I know that many of you already tackled this in your high school, and probably some of you will eventually tackle these things. I think we can skip to this. So if you remember, do you recognize this figure? Yes, it's a bell curve. So we're going to tackle about normal distribution and probabilities now. First is t-testing, unpaired and paired. So t-testing of independent variables is used to compare a single population to a standard value, for example, to determine whether the average lifespan of a specific town is different from the country average. The next one is paired-wise t-testing. It is used to compare a single population before and after some experimental intervention. For example, measuring student performance on a test before and after being taught the material. So independent t-testing and paired-wise t-testing is also used in clinical studies. So if you want to compare before and after effects, then you can use t-testing. ANOVA, analysis of variance, one-way or two-way. So you use one-way ANOVA if you want to analyze and compare the difference between two unrelated independent variables. For example, testing the relationship between shoe brands like Nike, Adidas, etc., and then try to relate their finish times in a race, in a marathon. Two-way ANOVA is trying to determine the relationship between variables and evaluate the significance of their differences. For example, you're not only trying to test the relationship between two brands, but you're also trying to connect or see the correlation between the brands, the runner age groups, and the race finishing times results in the marathon. So Spearman's rule, what is it and how and when should we use it? Spearman's rule is used to see the strength and direction of the relationship between ordinal or ranked variables. And it is especially beneficial in terms of social science studies. For example, example is amount of waste per household produced, and its correlation to the annual salary per household, and see the causal relationship between them. Okay, so yeah, you have to also consider ranks when using it. So chi-square method is a method or statistical test where you can determine the relationship between nominal or categorical variables. So it tests the significance of the difference between a set of observed frequencies and expected frequency, whether they indicate a relationship or not. So the farther the observed frequencies are from the expected frequencies, the more likely we reject the null hypothesis based on sampling error. And linear regression, you will use it if you want to identify how a variable X influences another variable Y. So it can be used in predictive analysis to see the outcome by identifying specific variables in the linear regression formula, and can be used for large volumes of structures and unstructured data. This is a statistical test that's loved by those who want to proceed to predictive analysis in artificial intelligence. An example of this is the population prediction of rural areas in the Philippines in 2050. Multiple regression. So it is a statistical test that can help show if multiple independent variables have correlation with a certain outcome or a dependent variable. Example is athletic performance outcomes of athletes eating vegetarian diet, carnivore diet, or fast food diet in 3 days. All right. Before I end the part 2, which is the statistical test, I'd like to mention that some of these will be demonstrated by other SIDHI mentors. Basically, we do not have to manually show you how they are solved, because there are already tools existing that can solve these things or can perform these statistical tests for you, such as spreadsheets. And I'll show you some links related to these as well. Right, we're already in the part 2, which is Introduction to Computational Linguistics for Social Sciences, Artificial Intelligence, Linguistic Engineering Applications. Some of you might be familiar, but I think it's just starting to be popular in the high school level due to the advent of artificial intelligence. So can you tell me if you recognize these apps? So if you guessed it correctly, the first one is Duolingo, second one is Memrise, third one is Rosetta Stone, fourth one is Grammarly, and the fifth one is Google Translate. So what do they have in common? What they have in common is that they are all products of linguistic engineering. They use intelligent algorithms to produce certain applications to teach, to translate, and to suggest. So what is computational linguistics? Computational linguistics is a combination of computer science and linguistics studies. So through the years, things have become interdisciplinary, especially if you have knowledge in computer science. So it's very important to learn data analytics now, because you can basically go to any field and have some sort of function in that particular area. So there are 2 types I'll show you just two types of linguistic analysis that is used in computational linguistics. Our first one is speech analysis, composed of some of these research fields or categories such as speech recognition, speech synthesis, and other sub-research categories. The next one is textual analysis. Textual analysis have a lexical, morphological, syntactic, semantics, and discourse analysis. We are going to focus on textual analysis. We can apply our skills in many specific ways, such as capturing real-world data, information prediction, corpus building, and/or building standards or structures for linguistic data. Okay, now I will show you the two approaches in linguistic analysis. The two approaches in linguistic analysis are theoretical and practical. In these approaches, we are going to focus on the practical part or the practice part, because these approaches are actually part of linguistics engineering, and the theoretical part you can also tackle the theoretical part. So as researchers in STEM, we're not limited to building devices and systems. So the practical part is in relationship with artificial intelligence. In computer applications, we try to bridge the connection between devices and systems so that we can communicate with the computers. And the development of tools is like developing another Microsoft Excel, for example. If you gained enough knowledge in linguistics analysis, and you can actually build some tools that solve certain problems that are missing with the current tools that are available. And then AI and machine learning, this is pretty much well discussed nowadays. So now we are going to proceed to corpus linguistics. So what is corpus linguistics? So corpus linguistics is defined in probably two ways. Well, and why corpus linguistics? First and foremost, well, corpus linguistics is sometimes defined as a methodology of linguistics analysis. It is also defined as an area which focuses upon a set of procedures or methods for studying language. So for the reasons why I chose corpus linguistics is because it's empirical. It is already structured, not in a way of structured data, but in a way where the structure of English text is readable and understandable in a universal way. And also it is accessible, it's widely studied already, it's textual, and it's cheaper. It's cheaper in time, in resources, because many tools are already available. And other reasons, not the reasons why, is because, okay, basically this section is some sort of more information about corpus linguistics and the things that it cannot provide you, such as to explain why a certain language is used, why certain techniques are used in a certain culture or language or sentence structure. And it cannot provide us negative evidence. It's not enough as a proof that something does not exist in the corpora. Corpora or corpus linguistics cannot predict some stuff. However, we can use other data analytic skills to try and proceed to predictive analysis or produce predictive models, because it's already used in machine learning. Other stuff that corpus linguistics cannot help us with is to provide probabilities. That's why we do try to supplement that lack of we try to supplement it with or integrate other tools and knowledge from other fields such as data analytics. All right, let's get started. Terminologies that will help you familiarize in corpus linguistics. All right, these are some of the terms that will help you familiarize with corpus linguistics. So what is a corpus? Corpus is a collection of machine-readable authentic texts. Another reason that I like corpus linguistics is because the readable texts that are compiled in a corpus is composed of real-world language, which are in forms of many written languages that are digitized. And now, what is lemma? Lemma is a form of word used to represent all its possible forms. Example, eyes, and its lemma is I. You'll be able to tackle these things when you proceed to natural language processing in artificial intelligence studies. So what is token? It's a final string that is detached from the primary text, or in other words, an output of tokenization. Now, what is lemmatization? Lemmatization is a process of determining the lemma of a given word. So there are tools and algorithms that can and does lemmatization, tokenization, and other terms that you'll encounter in case you delve or dive into this field. Keyness is an indicator of the importance of a word in a corpus. Keyness is a measured or determined by using chi-square method or log likelihood methods. Collocations is a sequence or terms that co-occur often that makes language sound natural. So that's what makes it interesting. N-grams. What are n-grams? N-grams are a contiguous sequence of n-words from a spoken or written language that can be used for word prediction. So n-grams are used for word prediction, sentence generation, and word embedding, and other uses that probably we might discover in the future, or probably are already in the progress of discovery. So chi-square, it has a different function. Chi-square shows the keyness or relevance of terms in a corpora. The higher the keyness score or the chi-square score, the higher the relevance of a certain value is. So the higher the frequency means the higher the relevance of the data in the corpora. So log likelihood is somewhat like a chi-square. However, it better estimates the low frequency terms in a corpora. So now I will show you how n-grams work. And I think this is very easy to relate with, because if you guys use Google suggestions in your keyboard, actually n-grams are used in your Google keyboard. So the first one, as you can see, n equals 1. You will see the pattern here. Every word is highlighted. And the second one, 2 words are highlighted. And for n equals 3, 3 words are highlighted. And it doesn't matter if they overlap. That's how machines are learned or are trained to learn how humans construct sentences. So we can use this for word predictions if we train the machine to adapt to these methods of writing and copy how we try to speak naturally in forms of text. All right, there are 265 tools in this website, which I'll link to you guys later. You can find here tools for text analysis, POS tags, word list, compilation, annotation, collocations, lexis, for spoken words also, for transcription, concordance, and annotation. It's available in this website and it's listed in the database. You can also use Python by installing the NLTK to analyze some corpora or build your own corpora. So these are sample or some simple things that you can do in NLTK. However, if you further advance to NLP, you'll be able to do more than just chunking or tokenizing or tagging text. Well, now I have a homework for you. I want you to build your own corpus and submit it to me via email. I'll post my email later. I was gonna show you how to build a corpus, but I'm afraid we're running out of time. It's very simple, and you can use you can just Google how to build a corpus. And if you have questions, you can message me. So some of the careers that you can go into or you might be interested in the future, it's up to you guys, but that's all I have for now. And I show you some things that might catch your interest in programming and artificial intelligence. I hope that you learned many things today. And for resources and links, kindly message me. I'll send you a Google Drive link or a document link if you have questions. And if you want to submit your own code, message me at medatup@gmail.com or message me in my social media me.dc.inc. And for mentorship, please contact SIDHI for their website. Visit their website at www.sidhi.org. In summary, we try to make complicated things simple as researchers, and that's all. Thank you very much.